It's not on. All right, everyone. Welcome to the 13th Plenary GA4GH meeting here in Uppsala, Sweden. Few things from me. So just so everybody knows who's here in the room, we are pleased to welcome nearly 300 in-person attendees. I don't think quite everyone has had breakfast yet, but they'll be here shortly, from 43 countries. We also have another 260 online that represents a total of 540 attendees across 48 countries. So well done, crowd. I want to give a really warm thank you to the program committee who put together an amazing lineup for these next 2 days of the plenary meeting. That's our chair, Per, Mallory, Oliver, Ika, Hamdi, Mamama, Mana, Johan, Shiwi, and Lindsay. So a round of applause for our program committee. They've been working really hard. I also want to thank our sponsors, certainly the SciLife Lab that's hosting us, and you'll hear from their director shortly. Also, Genome Canada, Illumina, Genomics Australia, and the German Human Genome Phenome Archive, all sponsors of this week's meeting. And of course, our ongoing support from our supporting funders, our core funders. Angela and I just submitted the NIH grant a week ago, and our host institutions that keep Global Alliance alive and running. Also, for this particular meeting, we have a number of themes that you'll hear throughout the next couple of days. Certainly, as always, a focus on global and regional perspectives on data sharing, European health data sharing, real-world implementations of GA4GH standards, the future landscape of genomic data sharing, making the case for data sharing to advance genomics, GA4GH supporting genomics in clinical practice at the national level, and applications of AI and ML and machine learning for genomics and global health. So lots of great themes throughout this meeting in the next couple of days. Also, just a few housekeeping things. So we'll have our plenary welcome reception tonight at 6 o'clock. And there'll be drinks and light refreshments there. It's about a 20-minute walk, so put on your walking shoes or take an Uber or Bolt if you don't want to walk the 20 minutes. And also, you should have gotten at registration these little drink tickets. Make sure to bring them with you so you can have a lovely drink on the house. And also, we're going to have the interoperability showcase. That's particularly where all the posters are going to be, and that will be tomorrow in Hall D. There'll be beverages and light bites there as well. And then a few other housekeeping things. So please join the 13th Plenary Slack channel if you haven't already. There's lots of people already in there. Me sharing that I lost my laptop on the way to this meeting. It's been a journey, my way to Japan and UK. Moving on. If you take any photos, post them there. You can find some already posted. Me and Melanie drinking sake in Japan after I lost my laptop. And also, we're going to have a group photo, so stick around after this first break. To have your photo taken, or you'll have severe FOMO. If you need to get on the Wi-Fi network, it's UKK guest, and that's the password if you haven't gotten on yet. Also, to protect health and safety, we do encourage you to review the full health and safety policy, respect others' decisions on there. There's the QR code. In case of a fire, there'll be a voice alarm. I'm not going to read all of this, but pay attention and follow the instructions. The assembly point is Vaksala Square. Okay, and there'll be security guards to direct you. Hopefully that won't happen. Okay, and just as a reminder, as always, please follow our code of conduct. We create an inclusive environment for all of our interactions, work streams, meetings, etc. We don't tolerate any sort of abuse, harassment, disrespect. And if you see anything happening in that regard, you can email conduct@ga4gh.org or reach out to any of the 5 of us who are on this committee. Both Angela, Alex, myself are all here. I'm not sure if Karen and Jimmy are here, but reach out to us. And then now is the time to make sure Slido is working, because that's how you'll voice your thoughts, questions, and so on. So if you don't have Slido up, scan the QR code and type in # GA4GH, select the room GA4GH 13th Plenary from Slido, and then submit your answer to the first poll, which is, what are you excited for most about the 13th Plenary? So do that, and then I'm going to advance the slide once. There we go. There we go. Collaboration. I like it. The people, I like it. Genomics in clinical practice, networking, teamwork, meeting friends, discussions, federated learning, data sharing. It's like joy all around. Health economics, GKS, latest developments, colleagues, meeting nice people, meeting folks from other countries. So many things. Holler for group hugs. Maybe after the photo we can have a massive group hug and all spread our germs to each other. No. Family reunion, great science. This is awesome. Love to start my day this way. Maybe you could all start my day this way every day. Wonderful. Okay, moving on. Well, that was what we just did. I think that's the end. Okay, now it's my distinct pleasure to welcome Mia Phillipson, who's the co-director of the SciLife Lab. Where is Mia? There you are. Thank you. Come on up. Welcome.
Thank you.
And one last thing that I forgot to do that Stephanie was like, you have to remember to tell them, if you got a little ticket for dietary restrictions, when you're at lunch, put the little card on your table anytime they're serving food, just stick it there, and then they'll know to give you as such. And this is for you.
Thanks. So welcome to Uppsala. I'm the co-director, as you heard, of SciLife Lab, and we are a very proud local host for this. The Global for Health, Global Health for Genomics and Medicine. Yeah, so I've been practicing all weekend. So Uppsala and SciLife Lab in particular have been involved in this collaboration with you for a long time, and we hope that you will enjoy your stay in Uppsala. This city is based on a long tradition of academic history. We have one of the oldest universities in Northern Europe. Uppsala University was founded in 1477. It's not on the picture, you will see it soon. There it is. And we are a full-bodied university, and as you can see here, this is the main building, and guarding this entrance, you have the different faculties here. History, medicine, law, and theology. I cannot really remember, but we are a full-bodied university at this time point. And we have also a lot of prominent researchers that have passed Uppsala University, and I just gave you 3 men, for example. We have Anders Celsius, who was the father of the temperature scale. Here we have Arne Tiselius, who developed the electrophoresis method and was awarded the Nobel Prize in 1948, and Svante Pääbo, who was awarded the Nobel Prize in 2022 for his work on ancient DNA and discoveries that are important for our evolution. But the most famous, still the most famous Uppsala researcher is Carl von Linnaeus. And he was a pioneer in creating standards and standardized the way that we look upon nature by the binomial nomenclature system, the hierarchical classification system for living organisms, as well as for introducing a common language, the Latin, when describing nature. As the Global Alliance for Genomics and Health is all about standards, I wanted just to remind you that this was actually started in Uppsala a very long time ago, putting standards on life science. So SciLife Lab, what is SciLife Lab? Well, we are a national research infrastructure, the largest of its kind in Sweden. And we have a pretty bold mission. We would like to enable life science discoveries that would otherwise not be possible. We were founded 15 years ago by the universities in Stockholm and Uppsala, but today we have technologies and research communities all over the large university in Sweden. And we gather scientists across disciplines. But we also collaborate with healthcare industry and governmental agencies, as well as internationally, of course. And since last year, we have a new director, Jan Ellenberg from EMBL in Heidelberg, that you might already know. So some user stats for our infrastructure. Last year, we served 4,300 projects corresponding to 1,900 users. The majority, as you can see, were, of course, academic researchers from Sweden, but 14% came from healthcare. In fact, we served 71,000 patient samples through the clinical genomics platform at SciLife Lab. We had about 300 international users and collaborations and produced more than 10 petabytes as our infrastructure technologies. And this infrastructure serves life science from the smallest molecules to large ecosystem. And the scientific areas that we focus on or try to gather research and infrastructure around are planetary biology, translation to healthcare, as well as the pandemic laboratory preparedness. The technologies at our infrastructure are award-winning in the sense that they were available at SciLife Lab prior to awarded the Nobel Prize, as well as or getting the Nature Method of the Year. And these technologies are open on equal terms for all researchers in Sweden. So the genomics infrastructure has had a big role in providing cutting-edge genomic technology for Swedish academic and clinical community from the very beginning. And this has ensured Swedish researchers and clinicians can access and adopt these breakthroughs early. And this platform is a partner in European genomics infrastructure projects. With this access of the SciLife Lab genomics platform, the clinical genomics platform, and Genomic Medicine Sweden, we cover this access all the way from tech development into clinical routine. And we've been very successful in turning technology and basic research into clinical solution. And as a concrete example, I can tell you about the long-read sequencing, which has been performed by Uppsala Genome Center at the genomics platform for a long time, with leading domain expertise in this technology. And this has allowed Sweden to be at the forefront of the technology breakthrough and to quickly pursue large European initiatives. As well as large-scale testing of long-read sequencing in the clinic. And this shows how early adoption and strong technological foundations allow you to make rapid clinical impact when the time is right. Currently at SciLife Lab, we are focusing a lot on how to establish a joint molecular unit at the university's hospitals in order to accelerate implementation of multimodal technologies and AI into precision diagnostic and care, as well as to enable innovative technology-based and data-driven clinical trials. So that is something that we are working on right now together with the university hospitals. But I just wanted to end this very brief introduction to what SciLife Lab is and Uppsala by talking about some recent research that I find interesting, that I think that you might have missed, but they might be anyway important to your field. And these are examples from Uppsala-based researchers. And first I wanted to talk about this science paper that came out last month, the early germline sequestration in a specific fungus that is growing here in Uppsala in these fairy rings that grow with time. So these researchers sampled mushrooms for 7 years and sequenced the different parts of these mushrooms. And as you can see, they found that the sterile and reproductive tissues had different kind of mutations. And this led them to suggest a new model for fungal heredity. So the classic model is that there is no germline separation, and mutation that occurs here in the mycelium is then passed on accordingly. Whereas the new model suggests early germline separation, also in fungi, as the somatic mutation happening here is then later found in the sterile parts of the fruiting body, whereas a mutation happening in the germline is found only in the spores and lamella. And why is this interesting? Well, it brings some new concept or a new idea on evolution and development. And now the next thing I want to show you, I will have to read because it's so fast, this movie. So this movie is based on discoveries from Johan Elf's laboratory. And this movie shows that the lac repressor protein scanning the DNA, when it's found its right sequence, it binds and sterically prevents transcription of genes. During the search, a single repressor protein scans the 5 million base pairs of the E. coli genome in 3 minutes. And the transcriptome factor search is believed to occur the same way in eukaryotic cells, but there these binding sites are shorter and specificity is instead achieved by involving a combination of many transcription factors. And here we have the Cas9, which is instead programmed with an RNA molecule to guide specificity and therefore has to unwind the DNA helix to test for correct hybridization. So these processes have been described in Johan's lab by in vivo single molecule microscopy, which has been developed here at Uppsala University. So with that, I just want to say warmly welcome to Uppsala, and based on your response to the question that I just saw, I think that you will have a lovely, warm and nice day here. Thank you.
If anyone has any questions for Mia, feel free to raise your hand about SciLife Lab, Uppsala, or anything else. Otherwise,
I'm not sure I can answer all the questions about this repressor protein.
I loved the movie, though.
Yeah,
it was very fun.
So do I.
Only all of our stuff looked like that. All right, I think we need a quick picture, and then... okay, catching all of you in the background. Yeah. All right, well, with that, thank you very much for opening the meeting for us. And I'm going to introduce Rob Anand from Genome Canada, who's going to moderate the next session and introduce our keynote. Patrick, come on up, Rob.
All right. Hi, everyone. Thanks, Mia. That was awesome. Heidi, thank you. As Heidi said, my name is Rob Anand. I'm president and CEO of Genome Canada. I am very pleased to be here in Uppsala for the GA4GH Plenary. Always a highlight of the year. Congrats to the organizers for pulling together a really exciting agenda for the next couple of days. As Heidi said, I'm chairing the first session this morning titled Global and Regional Perspectives on Data Sharing. This session here is meant to explore opportunities and challenges of genomic data sharing, thinking about how local priorities, cultural considerations, and regional infrastructures intersect with the international efforts towards data sharing. I know we have a couple of really great talks lined up. Between those talks and the conversation, I expect that we'll surface practical approaches and some new insights to shape a more equitable and representative data sharing landscape. So to kick off, it gives me great pleasure to introduce Patrick Tan. Patrick is the Executive Director of PRECISE. He oversees Singapore's National Precision Medicine Strategy to advance healthcare through the Asian Genome and Data-Driven Solution. He is Dean and Provost Chair in Cancer and Stem Cell Biology at Duke National University of Singapore Medical School. He's won numerous prestigious awards, too many to list. I had the chance to visit Patrick in his lab last year and can certainly testify to the excellent work happening there. So, Patrick, the floor is yours.
Okay, well, thanks very much, Rob and everybody for having me here today. I'm really privileged to be able to share with you what we're doing in Singapore. The talk today is going to be 25 minutes. Just take a note on the, because that's what I was told. And I'm going to focus on the talk today on a few points. Firstly, it's a great privilege. We may not be the smallest country represented at this forum, but we're clearly on the bottom 10%. That's one area. But what I'd like to do that as a small country, how we've been able to think about precision medicine or precision health in order to drive three aspects for society: research insights, healthcare innovations, as well as creating economic value. And also the role that organizations like GA4GH, with the use of standards and interoperability, plays a very, very strong role in how smaller countries like ours can bring things of value to the table as part of this global dialogue. So that's what I wanted to set the stage with, and let's get going. So this slide is something that probably all of you know in different fashions in your own countries, that due to increasing healthcare pressures, costs are coming up, healthcare systems worldwide are under pressure. So in Singapore, we have an aging population. We're one of the quickest aging populations in the world, rising degrees of chronic disease, increasing cost of therapies, comorbidities, lots of healthcare demand, and healthcare workforce is decreasing. So how do we balance that? And ultimately, this is rising public healthcare spending, ultimately cannibalizing from other areas like research, social services, and so on. So in terms of this, how do we shift the needle on this rise? And this is where there's been a big bet in terms of how can we move healthcare from its current role, which is treating sick people with advanced stage disease, into more proactive, preventive healthcare, and really shifting the needle of how we practice medicine. And so in this spirit, the Singapore government a couple of years ago made a big bet in a program called Healthier SG, SG meaning Singapore, which is to enroll the entire population into a health prevention set of programs, ultimately tailored to increase health span for everybody. There are a number of different facets of Healthier SG that I don't have time to go into. Happy to take any questions. But for the purposes of this audience, I think there are two important areas that may resonate. Firstly, besides the usual metrics that everybody should stop smoking, everybody should exercise more, and so on, there will be a need for precision in identifying specific populations at risk for particular types of conditions so that we can intervene in them with more resources. Precision public health, if you will. The second aspect for this audience is that if you want to look at healthcare data sets that can predict disease before it happens, the genome is a pretty good place to start because you inherit it from your parents, and the effects of bad genetics starts way from birth, but you can modify these usually in fairly simple, modifiable, inexpensive ways. And so I think this is the role of the genome in being able to advance proactive preventive care. So in this spirit, we were asked under PRECISE to think about how we could bring precision using the genome into the Singapore healthcare system. And this is what we do in 3 ways. On your left-hand side is the idea that we need to collect data relevant to Singapore, which has a multi-ancestry Asian population, and not just on the left-hand side, in the middle part, other aspects of data related to healthcare, and to do 3 things on your right-hand side. The top one, can we use data, genetics, but interlace with other modalities to identify patients at increased genetic risk of disease, monogenic or polygenic, before it happens, and what are the strategies that we can use to do so, particularly for conditions that may be more reflected in Asian populations like beta thalassemia. The middle part is that once we know and can identify the groups, how do we intervene in them cost-effectively in a deployable nationwide scale that we can ultimately uplift their health and give these individuals an equal, equitable shot at career progression and life. And lastly, as a national program which works across all of the different aspects of the government, how do we put in the right regulatory policies, the right standards, the right codes of practice that we can deliver this sort of information in a responsible way, in a way that also protects the rights of these individuals that were sort of dealt a bad genetic hand? How do we do that? This is a tall order. So in order to do this, we actually focused upon a 3-phase program, which every phase is a little bit bigger, and we try to learn from each as we go from phase 1 to phase 2 to phase 3. Phase 1, that I won't have time to talk into, was a very modest proof of concept that can we develop a reference data set of the Asian population that will capture roughly most of the common alleles. And that was a database called SG10K Health, 10,000 whole genomes. And that's one of the driver projects for one of the federated NOMAD projects for GA4GH. I will have a slide later on. What I'd like to do in the next few slides is to go through what we've done in phase 2 that just ended in the middle of the year in thinking about those 3 aspects: research insights, healthcare innovations, and economic development. And then there is time, I'll focus on the next 5 years, which is our aspirations for phase 3 of the program, and ultimately trying to think about how do we bring genomics into a healthcare system. So let's talk about the research aspect for phase 2. And remember what I said about the priority of the government in moving the needle into health care prevention and disease prevention. And so we thought that one of the ways that we could contribute as a program, which would be to invest in a reasonably well-powered, given our small size, longitudinal population cohort, very, I'm sure most of you know about it, recruit individuals at baseline, collect as much information as you can, monitor them over time, and as the events accrue, we can see what are the early steps of risk that in itself represent points of potential intervention. But this hasn't been done for a multi-ancestry Asian population, and so we invested in this over the past 5 years. And this cohort is called Precise SG100K, and it's a lot of data here, but I'll highlight a few points that may be of useful. First, it's 100,000 individuals. They're consented for research and linkage to electronic health records, and there are a few points that maybe juxtapose that with other biobank populations all over the world. On your left-hand side is that the way that we've sampled SG100K is that it's meant to model as far as possible the demographics, the socio-economic status, and the healthcare conditions of the general Singapore population. So we're trying to tackle the issue of representation bias between the biobanks and the general population so that what we learn in this can perhaps be extended in a more facile way to the rest of the population. The second part is that we've collected a variety of different imaging, questionnaire, biochemical measurements at baseline for all these individuals. And all of these instruments, using standards, have been designed to be interoperable with other international programs, all of us, UK Biobank, FinGen, and so on, allowing this idea of once you standardize your own program, you open up opportunities for data collaboration and data exchange. And thirdly, in a collaboration with Illumina that I'll talk about in another slide, we've been able to perform whole genome sequencing on all of these individuals. Each individual, because Singapore has a national electronic identifier for everybody, allows us to link it to national scale electronic health records that allows us to probe healthcare data of these individuals when they receive events everywhere in the country. Singapore is a pretty small place, so not that far to run, if you will. But this allows us then to look at longitudinal outcomes, which we think is going to be a very, very important area where you can model your own health trajectories from birth to death. And this, I think, will be a very interesting data set that we could bring to the table as part of the global community. Just one example of a finding that has come out from this. It's the first of many that we hope to come, but I want to make a few points here. On the top left, this is a gene that was identified that was associated with atherosclerotic disease, and this is a gene called FDX1. But the point about the discovery of this gene on your top left is that it took the combination of different small signals aggregating these multimodal data sets together. So there's a bit of signal from the imaging study, the carotid ultrasound, along with a bit of the signal from circulating metabolites, but combining weak signals to weak signals, you got a strong signal, and that was a hit. So I think the future is how do we converge these different multimodal data sets where we can amplify small signals across so that ultimately we can find true biology. On your top right over here, and you can't see it, but the reason why we were able to find it was because the allele frequencies in the Asian populations allowed us to identify these risk variants in a way that perhaps, given the power of other Western studies, they were not able to capture because the prevalence of these risk alleles was not as strong. So this allows us to bring new discoveries to the forefront. But if you look at the effect size of these, they also then transmit back to Western populations, ultimately reinforcing the idea that while we are Asia, US, Canada, and so on, we are all governed by fundamentally shared biological processes of human biology, that by aggregating all of our information together, we can review these different components, ultimately to get a better sense of who we are and what makes us truly commonly human. So I think that's one of the aspects that I want to emphasize. Now, there are obviously many different questions that we can ask, and I don't have time to go into them from the precise SG100K cohort. But at the bottom right, you can see our data access policies. We are looking for partnerships. We do require, and this is one of the things, collaborations with a local entity in order to access the information, but we're trying to balance open access of this information in a way that ultimately returns a certain level of intellectual value capture back to the country. And this is one of the themes that we'll talk about, I think, during the subsequent sessions. Now, if this works as planned, touch wood, you will see a lot, the world will see a lot of new discoveries, new insights coming up, lots of papers coming out. I think the existential question for many of these programs is that what do you do after the paper? How do you translate that finding, that biomarker, that tool back into healthcare? And so we were, in phase 2, we also wanted to tackle that challenge, and in anticipation that ultimately data from biobank, data from all of us, data from precise engineering, from industry would ultimately need validation and deployment in the clinical sector. And so we conducted implementation pilots, clinical implementation pilots on your left-hand side, where we selected, because precise SG100K was coming online, facets, genetic features of known, unquestionable biological validity, but for which in Singapore we hadn't quite worked out the pathway by which we could scale the management of these individuals in the healthcare system. And so we undertook these on your left, and what we did in this case was to partner a clinical champion, expert in the condition, along with a health technology assessment and a health economics team, to think about how we could develop clinical pathways, based on implementation science, but ultimately in a cost-effective way that we could take back to the government to say, will you consider this to be funded not by research, but by the mainstream healthcare budget? And obviously they look at this with a great deal of financial scrutiny. One of the examples that I think is low-hanging fruit, and most of you may know about it, is familial hypercholesterolemia. It fit the bill as an initial clinical implementation pilot for many cases, highly prevalent in our population, about 1 in 140 in the Chinese population, a high risk of getting a heart attack around the age of 40 to 50, but you can intervene if you start diagnosis early in your 20s and 30s, which is about 20 years before we actually recommend lipid screening in the population. So that's why the genetics becomes very important, but you can intervene early and you can actually prolong the health care of these individuals so that they can have more productive years of life. So we developed a familial hypercholesterolemia use case, and on the basis of this, we actually brought it back to the Ministry of Health, and on the basis of this and other evidence, they've now decided to roll out familial hypercholesterolemia screening across the entire country, paid for by the Ministry of Health budget. And so this was one of the first countries to be able to have this on a nationwide scale, from the discovery, the prototyping in a tertiary care center, but ultimately nationwide, touching general practitioners and consolidation of resources like counseling where it makes sense. Now, the key is that once we have these genomic assessment centers by the funding of the Ministry of Health, these now provide the conduits for further genetic findings to be able to roll in so that we can deploy more and more use cases and ultimately receiving information from biobank, precise asteroid 100K, and so on. One area that I wanted to highlight here, because it's actually not something I've seen in other talks, is primary glomerular disease of the kidney, or PGD, or Alport syndrome. And this is probably going to be the next use case that goes into the Genomic Assessment Center. So Singapore has a very high diabetes rate. And the main problem with the cause of diabetes is the disease, but also the downstream consequences of that disease, including renal dialysis for end-stage kidney failure. And Singapore is actually third in the top 5 countries where the cost per individual of end-stage kidney disease is very, very high. But if we can identify these individuals with the genes related to Alport syndrome, which is an early-stage kidney disease, we can actually intervene with an ACE inhibitor and prolong the onset of end-stage kidney disease by over 20 years. And I think that this is going to be a very important area and a use case that we want to further develop, along with other ones like hereditary cancer screening, BRCA, pharmacogenomics, and so on. So I think that's the part about how this sort of information can drive healthcare innovations. Now, the third aspect that we want also to highlight is how can we, as a small country, galvanize this sort of information to create jobs for more citizens, increase industry spend into this sector, and essentially build up precision medicine as a new pillar of the nation's economy. So in Singapore, there's a buzzword RI&E, Research, Innovation, and Enterprise. And in this, we still trying to think about it, but we basically have a strategy where we are starting, it's like a rocket ship. At the stage 1, we're engaging the tool companies, the spatial transcriptomics companies, the sequencing companies, the people that are helping to generate the data. Mid-stage rocket ship is how we then can engage the people that are using the data to develop diagnostics, drugs, and so on, but ultimately leading to the top one, which is how do we engage venture capital, family offices to be able to drive innovations to create new startups localized in Singapore. So there's some progress on stage 1, stage 2, stage 3. Let me just go to them on the next few slides. So I talked about the deep partnership with Illumina to sequence the precise asteroid 100K cohort, but it wasn't just sequencing. They were able to bring in the expertise that they had in the Genomics England program to accelerate the quality and the expenditure on our sequencing, but also allowing early access to new products and services that we work collaboratively with them to improve that product that ultimately Illumina was able to take back to sell to their nations worldwide. So I think this has been a very nice example of a very successful private-public partnership. So in fact, that after Illumina, we've been able to launch it with the 2 other long-read sequencing companies, got them to talk nicely to each other, well, somewhat nicely. Because we all know that both of them have strengths and weaknesses, right? And now by combining them, and so we also wanted to use this to think about standards, I think, for whole genome sequencing, for long read, that I'll mention that. And one of the outputs of this long read program is what we think is the first South Asian complete T2T genome that is now on bioarchives and I think undergoing peer review. So this will be another reference genome that can be used as part of the global dialogue on precision medicine. Now, second stage, how do we understand how to develop drugs and products in disease process from this? And so through a number of years, we've been able to engage a number of the different pharma companies and biotech companies using this sort of information. And one of the areas that we're going to announce, and the press release is going to come out in the next week at ASHG, is that going to be announcing the setup of Asia's first multi-pharma PCC, Pharma Pre-Competitive Consortium involving 4 pharma companies that will represent, I think, a signature validation of the work that we're doing in the country. And we look forward to more. I think it's been very powerful to learn how big pharma thinks about this sort of information. The local value capture part we're still working on given our small size, but I want to highlight that many of the products we're trying to do, and I think when you develop your programs, is how can we have local companies participate in the program, develop the expertise, the reputation, and then they can take this and shop it around to the rest of the world. And I think that this is a strategy that we're trying to explore, and I'll be to talk about that later on. Now, GA4GH has been absolutely essential in all of these efforts. Here's one case working with the group from GIS, and I saw Oliver Hoffman's name a number of years to think about what are the standards that we want to use to exchange quality of whole genome sequencing data. This wasn't available when we started. But I'm happy to announce that I think at this meeting, this collaborative WGS standards, where a small country like Singapore can participate along with Australia and so on, are now able to set certain standards as part of a global consensus that we're very, very excited about. The other area that, so in this case, please look, and there's also a slide, I don't think it's here, about our participation in the Federated Nomad Initiative, where we're able to exchange data, yet still keeping certain levels of data provenance between our borders. We're so excited about GA4GH that I wanted to also say, and I have the clearance, that next year's plenary for GA4GH will be in Singapore. And so it'll be the first time. So we are very excited. The team is here. We want to hear what works, what didn't work, how we can improve so that you guys have a really good experience. And so this is something that we're very, very excited about. And thanks to GA4GH for the blessing. Last 3 minutes, I'm going to focus upon a sneak peek into phase 3, which is about how we bring it home and build up into the healthcare system. I talked to you about the population cohort of precise SG 100K. That is essentially a healthy population cohort. In phase 3, we want to also represent genetics related to the healthcare system and the health conditions that are present seen by the hospitals. And so we'll be focusing upon healthy sequencing towards sequencing of conditions. This will ultimately give us the ability to look at other types of questions where genetics plays a role, responses to therapies, disease progression that we could not quite address using SG 100K. But I want to end with one aspiration that is why it's still a research program that we're going to have 5 years to figure out. And I think with our participation, we know what we want to do. We don't quite know how to get there. And we call it SOAR. It's this idea that as we know more and more about every individual and features that influence their healthcare at different points in their life, it then eventually, if you need genetic data 2 to 3 times in your entire life, it just makes much more sense to take your genome, sequence it 1 time, and put it into a place where ultimately it can be sequenced once but analyzed repeatedly for the different use cases. And once you have that, it then allows us to store it in a very secure way. It allows us to be able to access it for research as well as clinical delivery, ultimately converging the clinical domain and the research domain, which I think is where all of us have to go if genomics is going to scale up. And ultimately, by doing that, we'll be able to take research findings, bring it into a healthcare system, and ultimately also take it and move into healthcare, ultimately creating a nationwide genome-informed learning healthcare system. So I think this is something that we're trying to get the design architecture done. And we think that this will be a very important area as we pursue with phase 3. So I'm going to stop there. I'm going to thank you very much for your time and take any questions if there's time. Thank you.
Okay, excellent. First of all, wonderful news that the next plenary will be in Singapore. Book it now. Exciting. We'll see everybody there again. Before we move to some questions, I just want to remind people a little bit of a housekeeping. We are taking questions via Slido. So I don't know if you still have your window open. I believe it's the same window for asking questions. We do have a few minutes here for Patrick before we move to our next sessions as part of the next speakers before the morning session. We have a few questions up here already then, Patrick. The first one is really around recruitment. The SG100K, wondering how challenging it was to recruit 100,000 people to participate and what strategies you used and what concerns you maybe encountered along the way.
Okay, so I think this one is it's a big question, and I just want to spend too much time, and happy to talk to individuals. I would say that firstly, having a very strong public communications message where you emphasized trust in the government, I don't get in governments, but having trust in in the Ministry of Health was very, very important for people to want to sign up. In our case, we actually had a dedicated recruitment strategy where we actually looked at the recruitment rates at different demographic groups and asked the question, well, are we doing enough here? Do we need to devote more resources there? Talking to the religious leaders, the community leaders also was another very, very important aspect. And ultimately getting some key people involved. We got our Minister of Health to participate, so I think that also showed that there was, and having him say why this is important for the healthcare of Singapore. I think those metrics, but we did watch that very, very closely, and some days that we were sweating a bit.
Yeah, excellent. Yeah, I think that leadership is such an important part of this. So that's really great. Looks like we have a few requests to share the presentation files. Obviously,
definitely.
Very impressed.
I think through GA4GH will be sharing those.
Excellent. Okay, wonderful. So the next question is around thoughts on how to bring together the data from your program with the other large genomic programs represented here, UK Biobank and others, so that we can create more global insights into human health. So you have ideas about how you're connecting with other international initiatives?
Yeah, so I think this is obviously why we're all here. On the one hand, we all understand that being able to aggregate and share this data is ultimately what's going to give you the most power for insights. At the same time, also, I think we have to understand we are living in a weird world where borders are coming up quite rapidly. Sometimes makes sense, sometimes not so. We're going to have to grapple with that as a community and find that balance. So I think areas like federated approaches where you can actually manage and track, audit, and access are probably going to be important in this phase of the global landscape. And I think having that dialogue like GA4GH is going to be very important, where we can have open conversations about this and find a pragmatic path forward.
Excellent. So there's another question here around cost savings and obviously a focus that you described at the beginning, the idea of moving towards preventative health is sort of driving at that concept. Are you starting to see some returns there?
Yeah, so I would say that it's not too bad. We are able to document a specific, very tight use cases where we're able to see returns. Very, very simple things. How do you improve the efficiency of healthcare? So I'll give you one example that I think resonated very well. The fact that we had a reference database of normal Asian genomes allowed our genetic counselors to filter that through so that the number of variants they have to look at pathogenic is about 40% less. So that immediately we're able to spin out and quantitate into workplace savings and so on. So I think these cost savings really need to be looked across the entire continuum. At the end of the day, I would say that it's a long-term play, and the cost savings need to be reflected not just to the cost on the health system, but the gains to society. And I think this is why looking at these programs as all of government aspects, where it may be a bit more expenditure, Ministry of Health, but Ministry of Trade and Industry gains, ultimately the whole nation benefits. So I think for the preventive health aspect, that sort of dialogue needs to happen, because one cost here is going to lead to savings here.
Yeah, I couldn't agree more. And I think this is an area where we can do more collaborative work internationally, because of course everyone's facing the same challenges as we make the case for the investment in these kinds of large scale initiatives. It's the accrual of savings in so many different dimensions over time that helps to justify the cost. And we're all facing the same questions from our national, regional governments and so on. So sharing that information is very important.
And it's also the other benefits. So once you have this effort, it brings in other industries, it brings in new research, it helps the university. So there are other amplification benefits that ultimately lead to the ultimate value of such programs.
Well, and especially in a case like yours, and it's similar for us in Canada, where you have that innovation element as well, where you're encouraging local economic growth, and the economics become that much more complicated. Okay, a couple of more questions here before we move on. Question about technical implementation challenges. Wondering about what you encountered along the way, and if there are more opportunities for standards to support some of those challenges.
So, this is a rapidly moving area. I would say one challenge is when we move from phase 1 to phase 2 was to move from on-premise computing to cloud computing, which, when we started, cloud computing wasn't quite as advanced. And so having to adapt some of it to cloud, I think, was one important area. I think something for GA4GH that we put forward for in the some of the programs is how do we move systems on one cloud provider and make sure it works on other cloud providers. It's not as trivial as it is, that ultimately you get the same efficiency. So I think those are because now the world's going to be dominated by 2 or 3 major cloud providers, but you want your systems to be working on all of them. So I think those are some areas and we're still trying to work on.
Yeah, and I think especially as national security concerns start to adjust the use of some of those national cloud providers, interoperability is going to be a major issue. Question here about whether your data can be accessed by people outside Singapore.
So I would say that there are different tiers of data that have different levels of so-called access. The Chorus browser for the 10K is opened as a website. It's very much like the Nomad system. You can access it. You don't just have to register yourself. You can download all of the aggregated allele frequencies as a file. So this allows you to look at all aggregated data with very, very light touch. So that's what we're trying to do to open up the data. For projects that do require individual line access, individual patient, individual access, there is a data access program, scientific committee that looks at each application, and the data access principles are on our website.
Okay, excellent. So I think we have time for, we'll maybe just do 2 questions here. The first is about the biggest challenge of phase 2, and then for phase 3, is there a plan to have a more deliberate focus around rare disease recruitment and research?
So I think the biggest, so we call phase 2 the proof of value phase. So phase 1 was proof of concept, phase 2 proof of value, showing to the stakeholders that this was valuable. Phase 3 is the proof of scale phase. And so I think that the challenge really was to engage the different stakeholders, Ministry of Health, Ministry of Education, on what they consider value, and to really intentionally build up those the narratives to understand so that the work is better appreciated. So I think that took a long challenge in terms of putting ourselves in the mind of the government's officials in how they look at and make their decisions.
Right, and then the rare disease question around phase 3.
So I would say that the rare diseases aspect is definitely going to be a major focus in phase 3. And this is an area that we obviously need to think about how we can couple other types of phenotyping so that we can accelerate not just the diagnosis but the treatment of these individuals. We're very interested in carrier screening also, where some of these inherited rare diseases, we can offer them to couples and maybe give them a choice in terms of do they want to carry on with their child. So I think those are things that we're looking at right now. But I think rare diseases will be a focus in phase 3.
Excellent. Okay, well, obviously a very impressive body of work happening in Singapore. Congratulations to Patrick and the team. Looking forward to being in Singapore next year. So first, please join me in thanking Patrick for his talk and the questions. This was really great.
Thank you.
Excellent, thank you. Now, Patrick will be rejoining us on stage momentarily. So the way the next session of this session is going to work is we're going to have 2 shorter, kind of more rapid fire talks, and then we are going to have a small panel discussion. with Patrick and the next two speakers. So,
we'll have a 5-minute pause. We need to get the table, and we need to get people off the stairs and into the audience.
right now?
I think so.
We're gonna take 5?
We've got time.
Okay.
Get everyone shifted.
Okay, we're going to take 5 right now.
Not
Just
now.
at the end, or before the
We
speakers.
just need to get people sat down off the stairs. While
Right.
We move the table and chairs on. For the
Yeah,
panel.
okay, so we'll do that.
Hello. There are a lot of people sitting on the stairs and over on the sides. And
my goodness.
we need to get all of you into seats so that we can, well, I think fire hazard, but also there's some logistical
Lots of
things.
room.
So we just want to take a few minutes for people to move to the center and let everybody else sit down, please.
That's how I should have done it.
Okay. Do you want a hand? Okay. Ready to go? Yeah? Okay, am I on here? Okay. Thank you, everybody, for the brief little bit of housekeeping. We're going to get back started again. Unfortunately, Dr. Melendez Zegla hasn't been able to join us today. So we're going to have two speakers now, and then we're going to have a brief, as I said, sort of Q&A panel discussion. So if you have questions, do continue to put them into Slido. So up next, very excited to introduce Binay Panda. Binay is professor at Jawaharlal Nehru University in New Delhi. Studied and worked UK, USA, Japan, Denmark, all over the place. He also co-authored India's first biological data sharing guidelines, published by the DBT. So, Binay, the floor is all yours. Thank you. Great, thanks.
Good morning, everyone, and thank you very much for the introduction, and thank you for the invitation. So if you want to know the contrast between Singapore, what you just heard from Patrick, is going to be the next talk. And I don't want to scare you, but India is scary even for Indians. And when I have friends come and tell that this is scary, I said, welcome. Okay. So this is just a standard disclaimer. What I'm going to talk to you about is my view and not the view of my employer, the university or the government of India. And I'm going to tell you very early days about data sharing. And data sharing is, as you heard in the beginning, is part cultural and part legal. So we are trying to figure out from the legal terms that how data can be shared from India with people outside of India and even within India, and what can be the repercussions of not sharing it. So I'm going to talk about a little bit about India in one slide, which you know is very difficult, but the diversity and the challenges it brings to all of us within the country and also outside of the country, and then slowly take you to the early days of the legal ramifications or the points on data sharing, personal data sharing, where the genetics or the genomics data is a part of, but the personal data sharing is encompassing everything on the healthcare data, including genomics. And where we stand and what we have to learn from all of you, and that's the best part of being in meetings like this, to learn from all of you the best practices and how we can incorporate those best practices within our geography by keeping in view of the cultural standings. Okay, so for Europeans, this is probably nightmarish. As you can see, we have about 23 official languages. This is more than Europe. And these official languages are not just dialects, these are languages with distinct history. They have all their own dialects within those languages. They have different scripts. And there are more than 122 major languages in India. And there are more than 30 languages which is spoken by more than 1 million people. They have completely different histories. So as you can see, this is not just nightmarish for you, for us also. But I think this is the uniqueness about our country, that we present really a diversity and heterogeneity which is the cradle of understanding genetics. But also it brings specific challenges. All these languages of more than 1.4 billion people, they fall in 4 different ethno-linguistic groups. As you can see, this is a color-coded graph of different languages. And growing up as an Indian, it's very common to be a tri or a tetralingual and switch effortlessly between and among different languages. So when I hear the debate in some of the countries in the West that you cannot switch between 1 or 2 languages is music to our ears. So we can effortlessly switch 3 or 4 languages without any problem, because that's what we grew up with. And some of the recent works by David Reich's group and also All India Institute of Medical Science and also Priya's group in Cal actually put together the history of Indians. Now, there's a single event which started more than 50,000 years out of Africa, and then there were 3 major groups of Iranian farmers, South Asian hunter-gatherers, and the steppe population where there was a huge admixture. And this admixture actually went through a strong population effect about 5,000 years back. And this is the modern Indian population that you see today. Now, because of this strong founder effect and the bottlenecks, we have huge number of multiple endogamous groups. They marry among themselves for the last 5,000 years. And this is actually where the disease genomics cradle lies. Because of the power of many of this heterozygous mutation, you have really a group of populations in hundreds that can actually, for the first time, we can discover new mutations which give rise to a particular disease which remain within that small population group. Now, so far, it's been very limited in India what genomics data provide because we didn't really sequence a lot. For the first time, we have sequenced about 10,000 different individuals, and these are new data, not yet published, but 10,000 different Indians following 80 or 90 different endogamous groups, so there is a chance of discovering some of the heterozygous mutations that I'm talking about that are prevalent in certain subpopulations. And before that, most of the genomes actually were exomes and very few whole genomes and a lot of targeted site mutation in cancer, but in the other diseases as well, but primarily in cancer. We did not have a data sharing policy before 2021. And that is exactly the time, and I'm a part of the group which is put together this promotion of research and innovation of data exchange, the PRIDE guidelines. Now, many of us who are researchers should know that guidelines and policies are not legal frameworks. So this is a very important thing to keep in mind, that you have all follow guidelines. But we didn't have actually a legal framework of the law, and I'm going to talk about that in a minute. Now, following that PRIDE guidelines and the data exchange, which is called the FEED protocol, we are in a process, or we are in a time that we can actually share genomics data with some caveats. Now, the stakeholders are primarily two, but there are total, as you can see here, 6 different stakeholders. One is producers and one is users. Now, producers are data fiduciaries. It could be a service provider, it could be a hospital, it could be a startup company, it could be an academic lab, who gets the sample from users. So there are distinct legal languages that actually are in place right now for privacy. And this privacy is not related to genetic data privacy, but the privacy in general that actually pertains to both producers and users. So users are data principals and producers are data fiduciaries. Now, mostly the users are responsible for providing the right information to the producers. Producers are responsible of getting consent and making sure that the consent is very, very accurate and specific. And towards the end, I'm going to talk about why this opens up a very interesting paradigm for the legal researchers. What do you really mean by specific? Because when you are giving, and this is digital data privacy, so when you have to be specific many times as researchers, we really do not know what we are going to do with this data. Because, for example, I am collecting data for cancer, but the same data can be used for a non-cancer. Am I actually eligible to use that? So it opens a lot of questions which we don't know the answers. Now, outside of these producers and the users, there are obviously custodians, the data center, the funders, mostly the government, and the data management group. So the data management group is like a study section where different experts come and they actually judge the applications if you have applied to get the data. So I don't know why this has come like that, but anyway, there are 3 different tiers of data: open access, controlled access, and no access. Now, we still don't know, this is early days, what no access would mean, because there are a lot of endogamous groups, tribal groups within India, and I'm going to give you some of the examples from the US that what has happened in the past and what may happen in India. These are early days, that how we deal with sensitive data. Of course, in Europe, as you know, anyone who comes to Europe, the first thing you do is that when you open the computer, there are a bunch of privacy things that you say yes or no. That's the first thing you realize. So GDPR, of course, is the most stringent form of access of data. But in India, we have to be stringent at the same time. We can't be too stringent, because about one sentence about India, I must tell you, everything that you know about India is right and wrong at the same time. So if you just remember this sentence, I think you are sorted about India. Everything about people, about food, everything. Indian food is very spicy, yeah, but we have also non-spicy food. Indian people are X and Y, but also we have opposite. So it's really a country of contrasts. So you have to really understand each and every nuances before making a decision. So no access of the sensitive data is early days. We have to see how sensitive data is dealt with. Okay, so this is a very important part of privacy. In our constitution, privacy was not mentioned before 2017. And there was a very landmark judgment of the Supreme Court of India in 2017. It's called Pottasamy versus Union of India. And it's for the first time that privacy is now considered a fundamental right. And as an Indian, we hold our constitution to be supreme. We really like being a democracy, rather a chaotic democracy, but we love it. And we hold this to the esteem that the privacy is now considered to be a fundamental right under the 21 article of the Constitution. Now, privacy can be physical, can be intellectual, can be informational. So as you can see, this encompasses everything. So there would be a time if somebody has taken the genetic data from you and have used something for which you consider to be a breach of privacy, they can actually take you to court. So this, for the first time, defines that privacy is important. Okay, now we have an act from 2023, is yet to be implemented, and everything comes under the digital data is actually on digital personal data protection law. Now, what does this law say? It doesn't say anything which is sectoral specific. For example, it goes across different sectors. This is for the first time we have a legal framework of personal data. Now, as you can see, personal data is not defined. Everything is personal data. Now, there are, of course, limitations to this, but it covers everything personal data. Now, the problem is healthcare in India, before a couple of years, was a lot analog. It wasn't digital. So there are still legal quandary right now is that how do you deal with something if a clinician's prescription, which is on a piece of paper, that's analog, that's not digital. So it doesn't come under this preview, but the moment you scan it, it becomes digital. So a lot of hospitals right now, if many of you getting Indian data, I want you to be very careful because right now we are in that transition of making this law applicable. A lot of US researchers, for example, have gotten data from India because there wasn't any law, now there is a law. So anything can happen, these are early days. Anyway, so the only criminal effect to that is you cannot de-anonymize the data. That's the only criminal effect. And of course, it provides the sovereign control of the data to India. There are a lot of questions. I know even we have questions, so these are early days, but for the first time, we have a law that actually governs the healthcare data as digital data, including the genomics data. Now, the most important part of that law are data principal and data fiduciaries. These are the individuals where you get the samples. These are the individuals who use the sample. Now, as I mentioned at the beginning, the most important part of the data fiduciary is the obtaining consent. And remember, this consent has to be complete, accurate, and consistent. And you have to make sure that you have to give the exact reason for which you are actually deriving the consent, which can be anything. Now, the role of data principal, the individual who is giving the sample, you have to make sure that you are giving correct information, but at the same time, the law gives you right to erase or nominate or change if situation changes. For example, you become incapable of moving, you can actually nominate some of your family members to have access to that particular data. Now, the rest is pretty simple. As you can see, it actually gives you the authority of a data protection board. Data protection board gives the judgment if there is a breach, what to do and what not to do. And the problem is that it doesn't create a minimum standard for sectoral specific data. For example, what is the minimum standard of a genomics data? It doesn't say. It leaves it open to a specific industry to come up with those standards. So we are actually thinking about sitting and maybe discussing within the groups, genomics group or the healthcare group in large, that what should be the minimum standard that should adhere to. But the problem is that we can give guidelines. It's not law. So if there is any problem or somebody drags anyone to court, then it's up to the court to decide what is or isn't minimum standard. The second thing is it doesn't actually address the portability issue. And in some cases, it does address the localization, particularly in the case of Reserve Bank of India, which is financial data. Remember, I'm talking about digital data. That means any data under sun is digital data. And the bottom line is that it tried to do a pragmatic balance between using the data for innovation while preserving privacy. So it's not detailed, but for the first time, we have a legal framework. So in the healthcare sector, I gave you one example of analog data and how it can actually create challenges. But at the same time, in the healthcare sector, there are two important aspects that we have to remember if you are a large hospital or a large service provider, or the public sector labs like public universities and research institution labs are not large enough. But if you are large, the most important thing is that you probably have to appoint a data protection officer, make sure that the data security is properly in place, is publicly available, and is audited. That's the most important part if you are a large service provider. Now, there are some examples of what healthcare workers actually want this law to be. First of all, if a consent is given by an individual to the data fiduciary, then in the verbal consent is given, that's considered to be a consent. That's what they want. Number two, they may share, because right now, if a patient walks into a hospital and talks to his or her clinician, the clinician may sometimes over the phone, or because in India a lot of things happen over WhatsApp, may actually consult another friend. In that case, the medical practitioners want this to be considered as consent, because many times you can't go back to the patient and actually get a written consent again. It's not possible. Okay? Number three, the data fiduciary may store data during treatment and follow-up, even without explicitly being mentioned in the consent form. And the fiduciary may use the data in research after obtaining consent, the IRB approval, and pseudo-anonymization. And the most important thing is the annual security vulnerability assessment is done by the data producers. Now, these are the wish list from the healthcare workers. This wish list is going to grow, and I'm sure that our own wish list from the genomics research point of view is also growing. Now, how much of this is adopted nationwide is still to be seen because these are early days. So essentially, at the end of the day, you have two layers of data protection, one layer at the level of an individual who is giving the sample. The other layer is the level of companies, hospitals, and large service provider who maintain confidentiality, privacy, and security, and anonymization. Okay, this probably is one of my last slides. These are the three landmark cases in the US. Many of you might know these are all cases which went to court. These are the cases where either the consent in the first case was given for diabetes research, but the court had to decide because the individual, one of the tribal groups decided that the research was outside of diabetes in schizophrenia and all, so was it right or wrong? In other cases, first of all, is it okay for the hospital to share data outside of the exact consent? And the third case is whether you can do sensitive tests like syphilis in one particular population, underrepresented population. The reason I mention this as a potential case is because if you remember, I told you there are many endogamous small population in India. So if you are a researcher sitting in the UK or Sweden and you got some data from India, from Indian sample, then there is a potential possibility that you could be asked to go to court because the consent form didn't actually agree for you to look at disease X and Y. Yeah, I'm almost done. So the point I'm trying to make is that it didn't exist before, so the data that you have, you still have a lot of Indian data outside of India, starting from HapMap days. Now, you heard in Singapore, 15% of the population are south of India, particularly one particular state of India in Tamil Nadu. And also you have the UK Biobank, Genomics England, there are a lot of Indians. But these Indians outside of India are not from all the regions of India. They are from specific regions of India who, for example, the people who like to travel outside, more entrepreneurial. But the data from India is more going to be representative of all the regions of India, and most importantly, those endogamous population where the recessive disorders are actually more prevalent. Okay, so I think we have a lot to learn from GA4GH. I'm a part of course, the REWS, the work stream, but I'm here to learn from all of you. Please let us know what we can do and do not do, because these are early days, so that's a good thing. And probably take it back home and try to implement some of those within India. With that, I think that's the conclusion, that these are early days in India. The law is in place, but the implementation is yet to take place. And we don't know how things will be planning out in the next years and decades. And I think it'll be great to learn from the community as a whole what we can or cannot do in India. With that, thank you very much. I'd love to take some questions.
That was really great.
Thank you.
Yeah, thank you. Okay, so I think actually we're going to move to the next talk. So Professor Panda, if you want to just grab a seat in the auditorium, we will bring you back up for the discussion. So up next, Dr. Hyun Park, who is the director of the National Institute of Health in South Korea, instrumental in advancing rare disease research, women's health, and precision medicine in the country. Dr. Park, the floor is yours.
Thank you for kind introduction, and thank you for the organizing committee to give me a chance to share our experience on data sharing. So, Korea NIH is a government research organization, and KNIC has a pivotal role in biomedical data protection and data sharing. It leads operating large-scale cohort studies, as we do have the biobank, national biobank, and we produce a huge amount of genomic data in Korea, and we also share the research data with our community. So currently, KNIH is operating more than 30 cohorts or registry. This includes cohorts from the general population or some specific group, like a neonate with a very low birth rate or transplanted patients. also we have the various disease-based cohort. Several of these cohorts are actively participated in international collaboration research, as I know. SCOGES is it means Korean Genome and Epidemiology Study. It was started in 2001. It's one of well-known cohort study in Korea. It recruited more than 200,000 participants by the end of 2014. And some of the participants have actively followed every 2 years, actively follow up for more than 20 years. We generated the genomic data from this cohort and share with our population. As to date, more than 1,800 papers come up from this cohort study. Last year, Korea launched huge national biobig data project. It aimed to collect the clinical information and biospecimen from the voluntary participant. So now we are generating whole genome sequencing data from the participants from the biosamples. So we try to connect the clinical data with both EHL and National Health Insurance data. So the data will be open several years later. And another key resources for biomedical data generation is National Biobank. As you can see, we have a huge national biobank, and we also operate and support the regional biobanks at the hospital. So we can show the biospecimen and generate the biomedical data using these samples. In Korea, we also have more than 30,000 whole genome sequencing data right now, but most studies are done using the Korean biobank array, which was developed in 2015. This biobank array is developed for the specifically for the Korean populations. At that time, when we used the other global diverse array, the genomic coverage was not so high. So that's why we developed our own biobank array. As to date, we produced more than 300,000 bio chip data and shared with the Korean researchers. And through the international collaborations, so we published lots of results. Through the imputation service based on the Korean reference genome, so you can get the vast amount of SNP information when you use the Korean biobank array. It's about 46 million SNP information can get, and that anyone can share and collaborate with the other data. Last year, actually, it really started this year as we launched the Korean Pangenome project. It aimed to produce telomere to telomere level assemblies from 1,000 Korean samples to 2029. By the end of this year, T2T level genomic data for the first 100 individuals is expected to be publicly available. And we also plan to be made publicly available via the Human Pangenome References Consortium. In addition to the genomic data, we produce lots of data, like an imaging data like an MRI, and we also produce the epigenome data as metabolome data. And recently we also tried to gather the life log data too. So now let's move to the data sharing issues. KNIH runs a central data repository. We call it CODA, stands for the Clinical and Omics Data Archive. CODA collects clinical and epidemiologic clinical and omics data derived from the National R&D project or voluntary data deposit. This system enables researchers to search for and recast the necessary data, and to perform analysis using a built-in analysis pipeline within the cloud-based infrastructure. This I'm sorry. This slide shows the data set provided by the coder right now. You can see the many, several kind of rare disease research project and public, from the public population and chronic and cancer research project. So we share this the raw data with the researchers. Anyway, when we share the research data with the human information, there are two main laws exist. One is Personal Information Protection Act, and the other is Bioethics and Safety Act. Under the PIPA, for the data sharing, consent forms must be specify the scope and method of the data used in research. Also, the bioethics and safety issue, the participant must be received adequate information how the data will be shared. So, as I mentioned earlier, so we have the central data repository, and it offers several advantages. In terms of ethical issues, it ensures compliance with the ethical standard through the collection of informed consent from the participant, and broad informed consent permits data sharing without the need for the additional consents. This makes it easier for the researcher to search and use this data. For data sharing, so we recast the clear communication of how data will be used, and ensuring participant confidentiality and data security, and also we checked adhering to the ethical guideline or legal frameworks throughout the research process. Furthermore, we recast IRB before they can access or analyze the data. For the international data sharing, there are three major ethical and social concerns. One is data sovereignty, and the other is the trust of participants. So the participants to question how data will be used abroad, and another concern is the use, the potential of reuse the data. So under the PIPA requires the strict consent before transfer the data, and also the PIPA requires that the researcher must ensure the same level of data protection abroad too, and the IRB is mandatory for the data sharing. So actually, in practice, overseas data transfer is the legally challenging issues. The KNIT, if the foreign researcher want to use our research data, so we recommend that recommend to the federated analysis model, in which the domestic co-researchers conduct analysis directly without transferring the raw data abroad. This approach enables secure and privacy-compliant use of big data while promoting global scientific cooperations. So anyway, recently AI-driven and advanced analytics require different or enhanced data utilization approach, and some complex machine learning algorithms often need a large-scale integrated data set and continuous access. So we need to develop adaptive data sharing model for domestic research or international research. Thank you. Thank you very much.
All right, thank you, Dr. Park. I think we're going to now, I'll invite the other speakers to the stage. Thank you, Patrick and Binay. Dr. Park, we'll have you sit and join us actually up here as well. And we do have a few minutes for questions. So please use the Slido to ask questions, and you're welcome to either address them to specific speakers, or if you would like, you're also able to just ask a general question, and we'll ask all of the speakers to sort of handle it. Maybe I'll sit here so I can sort of turn and look at the questions. Excellent. Well, a wonderful set of talks. Really, I think, valuable perspectives on international data sharing, some consistencies between the last two talks with regards to some of the needs and opportunities around data sharing, but also the challenges when it comes to secondary and tertiary use. I'm sure we'll have a chance to get into that. So we'll kick off first with a question to Binay. Are there standards emerging to draft consent form language across India? And is consent for research separate from consent for care, or is it sometimes combined?
As I mentioned, that there isn't any standard which is sectoral specific. We are still talking about different sectors coming up with specific languages. The short answer is no. The legal framework that I talked about is for digital data. It doesn't really distinguish what kind of digital data, and it throws open the entire field to come up with sectoral specific guidelines. So the answer is no, there isn't any language. But as I mentioned during my talk, it actually opens up a completely new Pandora's box about what is and isn't considered to be a breach of privacy. So it's early days. I would say that if you are using genomics data from India, I would be more specific in the consent. And I gave you the examples, the potential cases that might lead to somebody dragging you to the court. The consent has to be specific, what exact reason you are collecting the data for. To me, and this is just my view, the complications arise if there are commercial interests. Just think about a potential case. And I would actually love to hear about others, what they think. Suppose you are a researcher sitting in Sweden, and you have used some of the Indian data, and you have come up with a new tool, you have licensed that tool to a Swedish company or a company in the UK. Now, you're making money through those companies. You might be an academic researcher getting a kickback in terms of royalty or whatever. That's perfectly legal. But am I, as an Indian, can take you to court by thinking that you have used my data where the consent hasn't specifically mentioned that you can profit, but you have profited? So these are the cases which we don't know how they're going to be dealt with in the court, but just unless, and you don't know at the time of using the sample, you didn't know that you're actually going to make a startup company to make AI tool using the data from Sweden, from UK, from Europe, from India. So you couldn't have put those languages a priori. So you don't know that things will evolve. So I think it's open, you don't know. So to be careful, you can only be careful as much as you want at this present time.
Mm-hmm. Hyun or Patrick, either of you want to answer that question or respond to Binay? Anything? No? Okay. Hyun, a question here for you. International sharing is legally challenging in practice. So what are some of the specific challenges for the international sharing, and how could GA4GH help overcome these?
Yeah, actually, I'm not so familiar with the GA4GH. I don't know exactly. Anyway, recently we tried to the cloud-based analysis system, and so if the anyway, so we try to only provide the result, not access to the data. This is another issue. And another way is how about the federated model for the international collaboration? So we can put the distributed repository and to run the same process. So I'm not a bioinformatician, so I don't know exactly, but we can share it. Anyway, the summarized data already open through the several websites already in Korea. So you can access the summarized result like in GWAS or some variant calling data, but individual data is still as harder to share with outside the country.
Yeah, absolutely. So Guillaume has a question here, I think that's related, about whether tools like Beacon might be able to support sharing of variant frequency and so on. So do you see those kinds of tools as sort of helpful in terms of helping to bridge some of the challenges around personal data sharing? Yeah? Right. And Patrick, do you want to pick up on some of these challenges that have been identified by?
I would say that it often boils down to the specifics of why that sharing needs to be done. And I'm actually quite optimistic that usually if people are willing to put down on the table, this is specifically what needs to be shared, the intent, what are the anticipated rights of usage and so on, that this can be carved out in the form of a collaboration agreement that becomes legally binding. And I think that those seem to work reasonably well. So we have international sharing projects with certain key strategic institutes, and it's always a matter of really pinning down on what is the project. And I would say that people understanding that here are the rights of usage and the limitations of usage. And ultimately, I would say that doing on a case-by-case basis, I'll be quite optimistic that those tend to work out.
Yeah, I think that's a great observation. Binay, there's a question here for you, and it comes back to some of the comments you made around some of the subpopulations in India and protecting data for those subpopulations. And clearly the law is still sort of being implemented, and the ways in which this is going to live on the ground is yet to be determined. But I know it's a case for many countries around the world, including in Canada, where Indigenous populations and governance of data related to those populations is subject to special considerations. So I'm wondering how you see the future here, and how you think we can ensure that the policies and guidelines being developed will actually protect the data around those subpopulations.
I think I see the process to be more consultative with the groups like GA4GH and bringing the research community within India, at the same time government also in the force, because we have three different stakeholders. We have the researchers.
Oh, we lost your microphone there. 1 second, Binay. Maybe you can just try again.
Can you hear me now?
It's now.
Yeah, okay.
No, thank you. So I was telling that I see this process to be more consultative in the future, with different stakeholders playing a role. For example, the international stakeholders like GA4GH, Indian stakeholders. One is research groups like ourselves. And the third most important thing is the government. There also has to be some kind of consultation with the public, but the problem in a country like India is that it's not a monolith. As you saw, unlike in Sweden or in Singapore, which is a relatively small population, our population is not a monolith. It's actually a polylith to the big P. So, but you still need to do consultative groups meeting in maybe smaller villages, panchayats, what we call, and in subdivisions and districts to get the view of individual public, what they think. But also remember that often we forget, being genomics researchers, that genomics is not that important for a common Indian person, because our national priorities are very different. It's important to us, we are selfish in that way, but our national priority is to give clean drinking water, to make sure that infectious diseases are not well spread, to make sure that the public health is in order. That doesn't mean genomics is less important. It's important for us, but in a larger scheme of things, to answer the questions, how do we see those subpopulations coming to fold, is to build consensus in a consultative way. International bodies like GA4GH, the best practices from outside, research groups within India, the government policymakers. At the end of the day, the government policymakers are also the funding bodies who make the policies, are very important, and bring consensus within the country, which may or may not form into specific law, but form very specific guidelines and policies which we can follow. It's very similar to what exists in biological sciences research today. Recombinant DNA, for example, we have strong guidelines. So similarly, I think it's a consultative process among different stakeholders that will bring as many endogamous groups, small tribal groups together to make policies.
Yeah, thanks, Binay. And I think there's a lesson for everybody in a way. You know, India in some ways is a microcosm of the global situation. And even in cases where countries may seem like a monolith, there's always diversity within those populations. And ultimately, we all have a responsibility to try to think about the ways we address the variety of different concerns and needs of the populations under our global care as well. And so the lessons that you're confronting there are something that we all have to sort of face, certainly. There's another question here, Binay, we'll take for you here around the estimated timeline for the technical implementation to support data sharing, around use cases and requirements from India posing interesting challenges. So moving from the kind of legal framework that you were describing, can you just maybe comment a little bit on with regards to some of that technical implementation of the standards?
So the timeline was yesterday. And so no, I think from an Indian point of view, I personally think it's not important how fast we do it, but how right we do it. And I can tell you that no matter what, we are not going to be right in the first few iterations. There will be holes, there would be people who will, poke things here and there. That's okay. I think the most important thing, and this is one of the reasons why I'm here in this meeting, I was telling Peter, I was disappointed. GA4GH neglected 1/6 of our population, which is we. We have to be on the table not to dictate terms. That's not our intent. We have to learn quite a lot. And we can't learn unless we are there. We right now, and this is one of the things that I have, is that you can't do justice to the meetings. Most of the GA4GF meetings are 2 a.m., 3 a.m., 4 a.m., 5 a.m. Indian time. So there's no way we can participate. And I'm sorry to say, it's dominated by people in the US and Europe, and should be, because they are the torch bearers. But the torch has to come to us so that we can hold the torch at least for 5 seconds. But right now what is happening is that we don't get a chance to get to decide or speak in a forum like here what's important to us. And I think it's important that we are participating, we learn, we have a lot to learn from you. We have, at this point of time, probably the West has very little to learn from India in terms of the genomics data sharing and a lot, because we don't have a lot of sequencings and we haven't really done. But I think it's in our interest that we sit on the table, we listen to all of you, but have that chance to do that. So I'm here to learn, and I think I would be more than happy to learn from all of you what we should and shouldn't do going forward.
Yeah, well, Patrick?
Can I speak a bit of that? I would say that I think Singapore has benefited a lot from the use of standards, IC data encoding, internationally accepted standards, how you phenotype, how you sequence. Our feeling, and this is just a message, is that one day the ability to share will be there. It's a matter of time. And what you don't want to be is that suddenly you can share and suddenly you find your data is not compatible. And I would say that right now GA4GH has many standards that are in the pipeline. And at the very least, even if you're collecting as a sovereign unit, try to make sure that the data is adherent to those standards, because one day you will need to have a crosstalk. And actually those standards benefit you as a program. So when we started phase 2, when you sequence a WGS, there are so many metrics that you can collect about an individual genome sequence, but which one is the most important to monitor quality, reproducibly, which ones are perhaps less important? And so I think the GA4GH participation really helped us in thinking about these are the critical values that a WGS needs to be there in order to have sufficient quality to exchange. And this actually helps when you work with the sequencing vendors, because you know the types of specifications that you need to put into your contract that then will make sure that your data, even if it's within a province, will be super high quality. So I think the standards represents the collective assessment of the global community, or what are the limited numbers of features that are critically important, that ultimately one day will be able to translate across the globe. So I would say that it'll be there one day, but you want to make sure that your data is interoperable. Thanks.
Yeah, thanks, Patrick. I think that's really useful.
And also, I introduced briefly about the National Biobig Data Project. We also use the Illumina platform. And so we try to keep the standard and high quality control to generate the whole genome sequencing data. But the critical issue is that how much the clinical information we can get. Anyway, in Korea, so we have the National Health Insurance System. So all of the course study or national biobig data the participant can be followed by the National Health Insurance System, so we can catch up the clinical outcome. And we also try to connect with the electronic health record, which are located at the various hospital. It's another issue. Even we use the same common data model, but the information which the hospital is not equal. So that's another issues.
Yeah, absolutely, absolutely. I think in terms of sort of coordination and learning across different regions, to Binay's first point, I think while some regions may have sort of a head start on especially on the technical side, there's no doubt that everybody is constantly learning from each other as different regions confront their own challenges, and that's why it is important for considerations around logistics. For those tuning in at awkward hours next year in Singapore will hopefully be easier for time zones. We have two questions here that are related, and it's about working with industry. Yeah. And so both in the case of CODA in Korea, as well as Precise in Singapore, wondering about, first of all, the relationship with industry versus academics in terms of access to the data, and how some of what the opportunities look like, as well as some of the challenges. So maybe, Hyun, we'll start with you in terms of how industry is related to CODA.
Anyways, any researchers, even they are from the industry, they can use our data, but it's only for the research purpose. That means that they cannot use the data for selling or reshare with they cannot use those data for other purpose, only for the research use. And there is no know-how for the industry researchers. So anyway, I already mentioned so we requires so we recommend how So we request how data will be used. That is another issue, and how they keep the participants' confidentiality. That is the other
Okay,
issue.
so they have to actually, they request access, they have to maintain confidentiality, can use it for research, but the commercialization is somewhat limited. How about in Singapore, Patrick?
Yeah, so I would say that that's what's local and that's what's international. I would say that in the Singapore program, I mentioned this phrase RINE, the Economic Value Capture Initiative, as part of research and innovation is very, very important. And so many of these national programs were actually held to be able to balance these three factors. I would say the engagement of industry has shaped the program in a few ways. I'll just highlight them. The first one is that it's actually made the program better. If some of the software industry partners we've worked with, they can code and streamline much better than anybody in academia. I mean, the tools that the cloud providers provide for data security and so on are just industry. So having to work at industry standard is actually very sobering for academics. So it's really helped us to sharpen our focus, number one. Number two, it's when we work with industry, it's predicated upon our public engagement efforts, where we've asked the public, under what circumstances is it permissible to share data with companies with industry? And here you have this tiering of likes and dislikes, where if it's to create pharma, people are quite open to that. If it's something like a social media company, then the trust goes way down. So again, there's a diversity of companies that we want to work with, and that predicates the way that we engage with our data access sources. These industry partners do need to sign up to certain assurances. They're able to access data from other countries, but through a trusted research environment. And ultimately, it helps us to strengthen the overall program. So we actually view this as, again, case by case. We look for it. What's the win-win on both sides? And we see if we can develop a strong collaboration. This is not just for companies, but for research institutes also.
Yeah, thanks. Great perspective. There's another question now here, Hyun. It starts with you, but I'd be interested, certainly Patrick and Binay, if you want to weigh in as well, about data access committees and whether the KNIH hosts your own DACs. What are some of the successes and challenges that you've had there? Do you have academic researchers or just government representatives? So maybe a couple of words on how you've organized those data access committees, and then we can ask the other speakers.
Data. Anyway, Skoda has their own data access committee, so we review the proposal, how they can use our data. So and almost of the requests are so allowed to the researchers to date. As for the foreign research, anyway, I already told you, so we do several international collaboration research as a federated model. So if you can find a good Korean partners, you can use our own data too.
Good. Okay. Excellent. Patrick?
Anyway, recently, so we try to make some data the foreign research can use, but from the beginning, we try to get the permission to provide the data to provide abroad from the participant, like on the Panda project. So we got a consent for the third party, the foreign users. We try to. Yeah.
Excellent. Binay, do you want to pick up on the role of data access committees in India?
Yeah, so data access committee is a temporary, like a study section. There are different people, academics mostly, who is moderated by a government funding agency. They come together, but so far the way the decisions is made is exactly the decision is made in the funding. If there is a confusion, no access. So basically, if there is a borderline, it's early days, but suppose, for example, and this is something that if I can ask a question to Patrick, which we have a lot to learn from the 100K Singapore data that he showed, for the pharma company consortium, do you have specific languages that says that if the pharma company is obviously developing a drug or a companion diagnostics, is part of that profit royalty flow back to the society, or how is that dealt with? Because it's something that we can learn how to do it, but data access committee is primarily just a committee of academic people like myself, and which keeps changing from one term to another. The term is usually 3 years, and the committee looks at the applications that why you are going to use the data, and if everything is kosher, then just yes. But if there is a doubt, the answer is no, because nobody wants to take that chance if tomorrow there is a question, who is going to be accountable. So far, it's a safe bet. But I would love to know from Patrick how Singapore 100K SG, and in your third phase, how do you deal with the pharma companies, or if there are specific languages for profitability flowing back?
So I would say I want to talk about the data access committees because the devil's in the details of all of these issues. You can think of data in two broad buckets. There's data that's generated in the context of research funding. And so in this case, the whole genome sequencing, the phenotyping. And so that is, the data access committee there is, shall we say, perhaps a bit more in the academic set because they've received a grant, data sharing is part of that. You now have data that is generated as part of routine healthcare that ultimately you want to link. And that one is not generated by research funding, right? And I think that one represents a higher level of access that also boils down to the consent principles of the individual. So in Singapore, we kind of have two levels. If you want there's a lot of discovery and projects that you can do without even touching the healthcare data. And so that we have a data access committee for that, for the research data. And then the second level where there's a committee, and this committee here actually isn't anybody involved in the project. It's officials from the different ministries, and they look at it and ask the question, what's the value to the country? And I think so that and so far that's what the pharma customers, the pharma collaborators had to do also. I think that with regards to how we engage the pharma, it's not really benefit. We're taking a page from how a FinGen or UK Biobank have structured their collaborative relationships with them. I'm not sure how many pharma people are here, but it seems to me that one of the key, and I think perhaps even a stronger interest in their companies, is less to find new things, but it's how they can use the data to refine their current pipeline. And essentially what to kill, in a way. And I think that, so in that case, a lot of the IP is already protected already. It's just they're trying to cost optimize. And certainly there are new discoveries coming out. And I think that is really on a case-by-case basis. If it's collaborative research with a local team, then the principles of forward IP will apply. So, and this defaults to the standard way that we manage IP and intellectual property protection in Singapore.
Okay, excellent. I'm going to end with, we have just a last minute or two, so I'm going to end with one question for each of the panelists. There are still some questions on Slido. They will be gathered up and shared with the panelists, and you're welcome to come and badger them during the break as well. But I think the question sort of relates a little bit to one of the questions here that popped up about, kind of industry standards and how GA4GH should be thinking about those. But more broadly, from your perspective, in a sense, we're here at the GA4GH Plenary. What can the GA4GH be doing to help support the initiatives that you're leading, the challenges that you're confronting? What is, in a sense, your call to action to the community in terms of how they focus energy and so on in order to drive forward the work that you're doing? And Patrick, why don't we start with you, and then we'll work our way down the table.
Yeah. So I think we've been associated with GA4GH for a long time, usually fly on the wall aspects, but really thinking about what excites me about GA4GH is that despite the fact that we are different, we're all unified by this idea that the genome will underpin healthcare. I think that's what we're all here for, right? It's not just to write papers, but it will underpin the healthcare of the future, not far away, but near. And the organization like this is a goal of how we can learn from each other to work towards that common vision where everybody provides a genome for their own health, for their own benefit. And I think that this is something that the organizations like GA4GH will be very, very important to do, because in order to do that, you need the standards, you need the dialogue, you need the different experiences. Button knoppers under the ethical and legal aspects has been tremendously important. So I think this really is a clearinghouse for all things related to genomics data sharing. Thanks.
Excellent, thank you. Hyun?
As Korea, Korea is not an active member of GA4GH, but the both Korean governments and academic society try to follow the international standards. So if you made an international guideline or something, so we try to follow up, and I will try to active involve in GA4GH further. Thank you.
Excellent. Binay?
So the answer I'll give you in the form of an analogy is like the alternate fuel, the clean fuel. Everybody wants to go into electrification. So if you are in Scandinavia, I lived a few months in Denmark, I know everybody wants to get an electric car. But remember, in the global south, many countries, people don't have car. So if I don't have a car, my first choice is to get a car, not to get an electric car of Tesla, which costs probably $80,000. So I see GA4GH is great, but different countries and different continents are at different pace of adopting to the standard, making the standard. I see the next phase should be how to harmonize among different countries. And of course, you cannot bring the front runner, stop the front runner, so that you can push the people at the back. No, that's not the intent. The intent is to have multiple tiers so that in each tier, at least, they are harmonized to the next. So that's a challenge because you are thinking about, people are now thinking about spatial biology, single cell biology in the clinic. Trust me, in our countries, people don't even use PCR in the clinic. So I think we are talking about two different languages, and the translation is far off from research. So I see the future to be in different tiers, and each tier harmonized to the tier next so that we can bring everybody up.
That's a great perspective. Thanks, Binay. And I will note that there was a comment that once we're through Singapore, there seems to be a lot of support for coming to India for a GA4GH plenary. So
we would love that. In fact, you snatched what I wanted to actually request. We would love to have a 2027 plenary in India and welcome everybody to be there if they allow us.
Right, we'll pencil that in. All right. Thank you to my panelists. Really phenomenal discussion. Great talks and really great discussion. So once again, just a big thank you to everyone who gave the talk here this morning.
Thank you.
Thank you. And we are now going to do a group photo. So we're going to do it right here in the room. Instead of watching Angela try to communicate, why don't you just take the microphone, we can pass it to you, and you can provide instructions.
Yep. It's saying, I think it says it right there, but just stay in your seat unless you do not want to be photographed, which is perfectly reasonable. We're going to take it, I think, from here of the audience.